Number 19 of waves, they just want to test your knowledge about optical density of a medium. Okay, and then they give you 4 different options of, well, it's about proportionality of different stuff and objects of your waves. Okay, so if we look at waves for question number 19, we should know that to calculate your optical density, you need to have the speed of light in air, okay, or a vacuum, over the speed of light in that specific medium. And then you'll see that your optical density is inverse proportional to the speed of what it is. Meaning, if we change different optical mediums, the speed in that medium will differ. Okay? So, for example, we have a less dense, a less dense area, and then it travels into a denser medium. Okay? So if we say that the air, or the wave has an incidence ray, from less dense to more dense, it will bend. Okay, if we have our incidence ray over there and the incidence angle, it will bend towards the normal, and you know that the normal is your perpendicular line on the medium. Okay, so you'll see that if the densities differ, it will bend towards, from less dense to more dense, okay, and it will travel slower. Okay, that wave will decrease in speed. Okay, so you should know that option B will be your correct one, what states that the denser the medium, the slower, and we saw it from this, the slower the wave will travel, and the closer it will bend towards the normal of that object. Okay, so this is your knowledge test on different waves. You are still busy with waves. They want to know if you know that Snell's law has a kink in it. It has something that's a bit different to what we're normally used to when we're doing graphs. So we have our 4 options, and they want to know which graph shows the gradient of the breaking index, or the index of a different type of material or medium. Okay, when it travels from air to a new medium. Okay, so now we need to use our straight line graph and our straight line formula knowledge again. But the thing that you need to know is, if we use Snell's law, which is Ni sine theta I is Nr sine theta R. Okay, so that's our incidence and that's our breaking, the index of each. You should know that the thing that we can control as an observer or something is we can control the incidence angle, okay, the theta I. But the thing that travels or that works with the theta I is the sine. So you don't want to get rid of that, because if you get rid of the theta or the sine, then the shape of the graph changes. Okay? So this is our independent variable. So normally in graphs, your independent variable is on the x-axis and the dependent is on the y. But with Snell's law, this rule changes. So now our independent is our y-axis and our dependent is our x, and then you'll get a straight line through the origin over there. Alright? So what's the name of this gradient? Let's figure that out. So if the incidence index is 1, because it comes from air, we can ignore that. Okay? So this is, I'm just going to write it, that's air, and this is our medium. Okay? So let's reconstruct the formula so that our y-axis is in front. So that changes to sine theta I equals Nr sine theta R over Ni. And we just said that Ni is 1. I'm just going to say that here, 1,004 or something. So we can ignore that. So we're left with sine theta I equals Nr sine theta R. So from our straight line formula, we can say that Our y-axis is sine theta I, and our x-axis we can see is sine theta r. We know it's plus 0 because of the origin again. So what's left, that is the gradient, and the gradient is then nr. Okay, so I'm going to write that nr. So that's the breaking index of the medium. And then you'll see that the correct option that fits what we just explained will be option D. Number 21, they want you to go and figure out what is the critical angle. Okay, so the critical angle, if we have a breaking index for the medium to be 1.5. So the moment you hear the word critical angle, it means that the light beam is traveling from in the dense medium and is going to break on top of that specific medium to the lesser dense. So that means that we have all the incidence values, okay? Or no, one we want to have we want to calculate what that theta I will be, okay? And you should know that if it breaks on the angle, we have a 90 degree as well. So our n initial is going to be, well, not initial incidence, sorry, is going to be 1.5. We want to figure out what this is. We have nr because it's breaking to a lesser dense, so that will be air to sine 90 degrees because it's breaking there. Okay, and then if you do your quick math, divide the 1.5 away, get the sine theta will be, the sine theta I will be 1 over 1.5, and then the shift of that value will give you only the angle, and the angle, the critical angle over here is going to be 41.81 degrees, and that is again our option C to be the correct answer.